Hey everybody, I'm going to work through some examples on this study guide here so you guys can kind of get some work before your test on Wednesday. So I'll just kind of do one from each section. To approximate the square root to the nearest integer by finding the two perfect squares it falls between, we'll do number 2 here. What that means is, well, what are the perfect squares that are around the square root of 39? So we can, well, maybe make a list of the perfect squares if you ever forget. 2 squared equals 4, 3 squared equals 9, then so on and so forth, 4 squared. 16, 25, then we have, after that, 5 squared, 6 squared, 36, and then 49. So we know that clearly 39 is between 36 and 39, those two perfect squares. Okay, and we know 36 is 6 squared, we know 49 is 7 squared. So we know, well, it's going to be negative of that. So we know that negative root 39 is going to be between negative root 49, right here, which would be 7 squared, and between negative root of 6 squared, or negative 30 square root of 36. Okay, well, if we know that the square root of 49 is 7, we know that it's between negative 7 and negative 6, because 6 squared is 36. Okay, well, which one is it closer to? If we go up here, is 39 closer to 36, or is it closer to 49? And it's clearly closer to 36, so we know that the square root of the negative 39 is about negative 6. Okay, so that's kind of how you do those ones. Okay, for number 3, find the square roots of these two numbers. All you need to know is what numbers squared give me 625, and the answer is both positive 25 and if you did negative 25 in parentheses squared, that would also be 625. So when it says square roots, emphasis on that S, that means that there's two answers, positive and negative. Alright, simplify the following expressions by first factoring out any perfect square factors and applying product quotient properties. So these are the ones that I probably anticipate will be the most tricky. What you want to do here is, if you can ever divide something out, you should do that. 8 over n squared, I can't divide anything out there. 48 over 49, I can't divide anything out here. We'll do 6 here. Okay, well, this is the quotient property of radicals, which means I can rewrite this as a square root of n over this, or square root of 8 over the square root of n squared. And you want to factor out, to simplify these radicals, factor out any perfect squares that multiply to 8. Well, what is a perfect square that goes into 8? And the answer is 4. So you can write this as the square root of 4 times, well, you'd still have the square root of 2. Square root of 4 times square root of 2 gives you the square root of 8. Over, and then you can actually evaluate the square root of n squared. That's just going to be n. The square root of 4 is 2. Can't evaluate root 2 anymore or factor anything out, over n. That's how we get our answer here. Okay, so for 48 over 49, then you kind of have to reverse that process. You have to know that this is the same as the square root of 48 over the square root of 49. And the square root of 49 we know is 7. The square root of 48 we can simplify. What are the perfect squares that go into 48? And the answer is, well, a couple of them, but you could find that this is the same as 16, square root of 16 times the square root of 3. You can factor out 16 because that is a perfect square. And when you do the square root of 16, you get 4 root 3 over 7. That's how that one's done. Okay, 75m. That's the product property. That means it's the same as the square root of 75 times the square root of n. And you're asking yourself, what are the perfect squares that go into 75? Well, you know that 25 is a perfect square and that 25 goes into 75. So you can rewrite this as the square root of 25, square root of, well, 25 times 3 is 75, square root of m. This is going to be 5 root 3 root m. But why don't I leave it like this? Well, in the end, you basically want to combine all your constant terms, multiply those out. You want to multiply all your radical terms if you can. And this is going to be, well, the square root of 3 times the square root of m is the same as 5 times the square root of 3m. Basically, just reapply that product property. Okay, square root of 350, this is just the same thing. We're saying, what is a perfect square that goes into 315? And the answer is 25. Square root of 25 times square root of 14 gives you 5 root 14. So that's kind of how you do those ones. All right, Pythagorean theorem problems. When we have these right triangles, you want to use a squared plus b squared equals c squared. And then we're going to work on simplifying radicals, kind of like we did in the previous one. So we want to solve for the missing side length, keeping in mind that c corresponds with the hypotenuse and a and b are the legs. So our legs have a length of 8 and 4. In this one, we want to find the hypotenuse. Plug in your values. You know, this could be A, this could be B. You could swap those, it doesn't matter. And our C is our unknown value. So we know 8 squared plus 14 squared should equal C squared, which means C equals the square root. And I guess I'm getting ahead of myself a little bit. This is going to equal C squared. Well, 8 squared plus 14 squared. Well, 8 squared is 64. 14 squared, I don't know what that is. That is, plug that in, 196. So 64 plus 196. Add those together. You get C squared equals 260. And how do I solve for that? Take the square root. Keep in mind that our answer should normally be positive or negative, but since we're talking about when we're doing the square root of some variable squared, some quantity squared, you have to keep in mind it could be positive or negative, but our C represents the side of a triangle. We can't have a negative length, so C really can only equal the square root of 260, which if you plug that in your calculator, it's going to be not 11. I don't know why I wrote that. It's going to be 20. 20 squared equals, no, that's not right. What happened here? What did we do wrong? We didn't do anything wrong. We should get the square root of 260. I don't know what's going on here. We must have the wrong answer there, so that's my bad. But the square root of 260 is what are the perfect squares that I can take out of 260. And you might want to kind of write down the list, see what goes into there. 4 is probably going to go into it, and you don't necessarily want to start with 4 because it's the smallest one. You'd have to do a lot of factoring. So you want to find the largest perfect square that you can factor out of that. And that is going to actually, ironically enough, be 4. This is going to be the square root of 4 times the square root of 65, which is going to be 2 root 65. That's our final answer. You can always plug that back into the original equation, see if it's true. Does 8 squared plus 14 squared equal 2 root 65? All of that squared. That's going to be 4 times 65, which is, yeah, 260 equals 260. So we're good there. Okay, so our answer should really be 2 root 65. All right, next one here. This should be our right angle. This should be our right angle, just so that's more clear. So this is B, this is going to be A then. The opposite of the right angle is always your C value. Opposite of the right angle is always going to be C down here. This could be A, this could be B. So plug in your values, B squared, and then we have A squared plus B squared. So 7 squared plus B squared equals 9 squared. Well, 7 squared is 49. B squared equals 9 squared is 81. That means B squared equals 81 minus 49. 81 minus 49, which is 32, which means B equals the square root of 32. What are the perfect squares that go into 32? And you should recognize, well, this is the same as 16, the square root of 16 times the square root of 2, because that gives you 32, and 16 is a perfect square, which we can evaluate to be 4 root 2. So that'll be our value for B here. Okay, C is, number 10 is going to be done in a similar way to that these ones were done. All right, give 2 examples of numbers that are irrational. Just remember irrational numbers. Irrationals are numbers that can't be expressed as a quotient of 2 integers. So basically that just means if you take this and if this is a non-terminating decimal, whatever number you're working with is a non-terminating or non-repeating decimal, or non-repeating. If it's non-terminating or non-repeating, then it is irrational. If you plug in the square root of 7, you're going to get a non-terminating decimal. That's irrational. Pi is not irrational. Anything that's non-terminating or non-repeating is irrational. Number 12, I think you guys can handle that. Just make sure that when you're writing the original numbers, when you're ordering them, when you're ordering the numbers, you're writing the original numbers. Okay, distance and midpoint, that's the last thing we're going to work on here. And we'll do 13 and 14, and that should be enough. 15 and 16 are basically the same, just different numbers. So find the midpoint of this. Remember the midpoint formula, and I have D here, this should say M. The midpoint formula means it's when I have 2 points, -5 and 6, this is a rough sketch of where that will lie. -5, 6 will be somewhere here. 3, 8 will be somewhere here. Our midpoint, M, is going to be right in the middle there. It's going to be the average of the x values, the average of the y values. So it's going to be the average of your x values. Well, if there's 2 of them, you do x1 plus x1 over 2. And it's the average of the y values, y1 plus y2 over 2. And then you just plug in your numbers. -5 plus 3 over 2. Then we're going to have 6 plus 8 over 2. -5 plus 3 is -2. -2 over -2 is -1. 6 plus 8 is 14 divided by 2 is 7. And that is our midpoint that we get here. So we're good there. Okay, now our distance formula. Remember that you find that by constructing a triangle and using the Pythagorean theorem. You need to know that distance is going to be when you have 2 points, it's finding the difference in those x values squared plus the difference in the y values squared. Okay, so our distance then is going to equal the square root of our change in x values. Okay, and 3 minus -5 will be 3 minus -5 squared plus our change in y values, 8 minus 6 squared. Square root of 3 minus -5 is the same as 3 plus 5, which is 8 squared, plus 8 minus 6 is 2 squared. This is going to be 8 squared, which we know to be 64. We know 2 squared is 4. 64 plus 4 gives me the square root of 68. And, well, how do I go from the square root of 68 to 2 root 17? And you have to say, well, what are the perfect squares that go into 68? And the square root of 68 you can rewrite as the square root of 4. Since 4 is a perfect square, that is also a factor of 68. We factor out the square root of 4, and we're left with, well, what times 4 is 68? 68 divided by 4 is 17, so we still have the square root of 17 here. And then the reason we factor that out is because we can evaluate that perfect square. That square root of 4 is 2. We're left with the square root of 17. So that's kind of how you work through a couple examples here. If you ever have questions, make sure you jump on those Zoom meetings. They are going to be required at least once a week, so you might as well jump on tomorrow, ask questions before that test. Make sure you're ready to go. All right, have a good day, everybody, and make sure you are staying safe out there.